Hello everyone, welcome to my channel. So today we are going to do DP series third question, minimum ASCII delete sum for two strings. So basically this question, as earlier we were doing LCS questions only, so I have taken third question also on the similar pattern only. So this is also one of the variation of LCS only. And today I will let you know about the recursive method, the memoization and the bottom-up DP, and of course how you would come up with all three approaches, and then at the end about the time complexity and the space complexity. So stay tuned for the same till the end. So because the thing is that it could become lengthy as usual, because you had seen earlier videos also had become 30 minutes and so on, so this might also become that much lengthy. So let us start. So first thing, in our question we are given two strings S1 and S2. We are required to return lowest ASCII sum of deleted characters to make two strings equal. So the thing is that in this particular question we are given two strings, and in them we are required to select those characters. After deleting those, we can make the string equal also, and they are adding up as the minimum sum to our final answer. So these are two things which we are required to consider. So what two things are? First thing is that it should have the lowest ASCII sum of deleted characters so that it could make two strings equal. So these are the two conditions which we are required to fulfill. So yeah, let us now check for the examples which are being given to us. Then I will show you that how we can think about the same. So here we are given with C and E, and you can see that the sum is 231, and as per the explanation they are saying that we are deleting S from C at say ASCII value of S115 to the sum, deleting T from E at 116 to the sum. At the end both the strings are equal, and 115 plus 116 equals to 231 is the minimum sum possible to achieve this. So this is the thing which we would be doing in both of the strings which would be given to us, deleting one of the character out of both of them, and then after that we will add up them, and then they would be, actually we would be what I can say, because surely the words that I am saying it would be confusing. So the clear cut thing is that we are required to check one character from the first string, one character from the string 2, and both of them should be minimum of all, and then we need to add up them, and that would be the minimum sum which we would be returning. And after deleting from first and the second string, the remaining string would be equal. So this is the thing which we would be doing. But the thing is, here it could be possible that there is just one character which is deleted from string 1, or there could be more than one character which are being deleted from either of the string or both of the string. So this is the thing. Now let us check for the constraints. So the constraint is that both of them can at max go till 1000 characters, and the S1 and S2 both are having the English lowercase letters only. So as per these constraints, here recursive method we can go ahead, but then the recursive method, because the thing is that we are required to go ahead with all the choices, and because of all the choices only, the solution would be simply in the exponential time, and that's the reason we would be required to memoize it so that it could go ahead with n square solution. So yeah, and if it will go to n square solution, that is valid for the same, because if it is n square, because here the thing is 10 raised to power 3, and in this order of n and then n square, that would be 10 raised to power 6, right? And that is also acceptable, and it won't give us TLE. So that's why here n square solution would work. So now let us go ahead with how we are required to do this particular question. So here I have given the explanation. So it is similar to LCS, where we were having the longest, and there also we were about to say choose or not choose. Here on the basis of minimum, because at the end we are required to run the minimum sum, right? And there we were checking for the longest common subsequence. So we were going ahead with the things that at every stage we were selecting the maximum out of both of the choices. But here what we would be doing, minimum out of both of the choices. So presently I am just building up the context, then with the example I will show you that what all these things I mean. And the second thing which we are required is that add that minimum to final answer at each step of moving ahead. So let us take this first example and go ahead. So here C and eat, which was given us with the first example. So we selected as S, whose ASCII value was 115, and T, whose ASCII value was 116, and adding up both of them gave us 231, right? And after deleting them from both of the words, what we got, it was EA and EA, and both of them are equal, right? So we got a desired result with the minimum sum of deletion. So this is the thing which we want to achieve. Now comes the next part, and this is the main thing which we are required to do. So see, then we are required to choose a particular character or not to choose, right? So here tick simply represent that we are choosing from the first word, and cross simply represent that we are not choosing from the first word, and that is we are choosing from the second word. Now here you can see in the first, if we are choosing from this first word, right? So SE and A has been deleted, right? So A comes into this sum, and now here I am writing just with the alphabet, although the ASCII characters, ASCII values of these particular alphabets would be added to this sum. But here, just for convenience and not for just remembering that what the ASCII value is there, so that's why I am directly writing the A character. And EAT would be as it is, right? And if we see for the next, when we are not required to choose from the first word, but we are required to choose from the second word, so what we are doing here is, we are directly writing this T here, and then in EAT, we are deleting this T and then writing this, and in the sum we got the T. So this is at the first stage what we got, but still they are not having any of them equal. So now let us go to this particular branch completely and check when we can get to them. So now we can select or not select. Again, two choices we are having, right? So till now in our sum was having A, and then in that we deleted from first word, that is we deleted E. Now there is S and EAT. So in our sum we got A plus E, right? And then again we have to choose, not to choose. So when we have choose from the first word, in this what we can do is we just chose from this first word, and now we chose, so S, E, A, all three were in the sum, and T was already there because of this particular, and then again we will be moving ahead and completing this whole word. Now because of the fact, because one of them completely became blank, right? So that's why now we will be making other also blank, because now there is only one possibility to make them equal, that is making both of them blank. So that's why at this particular position we are returning with T, and then again it will be coming up, and the whole particular this would be returned as it is. Means basically eat and then E, A, that also would be returned. Means whole of them would be returned at this particular position. And same is the case for this particular branch also. When we are not selecting, then again here again blank becomes, so now every letter would be returned, and here also again the same is the criteria which will be going ahead, right? So now you can see that every letter is returning, right? So when our answer will come. In some of the branch, here when we are not choosing it, means in this particular case, when we are not choosing it, then SE and EA comes, right? Then again the same criteria follows the way in these branches were there. And here again the same thing is following the way here it was. So now let us see in this particular branch, are we able to do so or not? So now here we see that now we were having only T at the first most level, right? Now we come up to second level, and in this level only we see that here you can see that A is equal and here A is equal, right? Both of them are equal already. So why we would remove any of them, right? So now what we would be doing is, we will be moving ahead with both of the pointers from the both of the words towards the next word, that is E. So now again both of E and E are equal, right? So why we would ever eradicate any of the words from them, right? So that's why now we will be moving more ahead. Now the pointer comes to S and the other pointer comes to -1, right? So now at this particular point, the thing would be when one is less than, right, and the other one is basically at the 0th position, right? So here T, which was already there, right, and the other letter at which the pointer was, it would be returned, right? Because here again the same case is there, that E and A were equal, okay, but still one of them got exhausted. So whatever remaining string which would be there for the other word, now that would be also removed so that both of them become equal. And here you can see the case that E and EA are now equal when S is being removed and T is being removed, right? So now this becomes our answer rather than when all of the words were being returned, right? So this is the one where the minimum possibility is there that T plus S, when we add them, rather than adding up SEA plus EAT, all of them, right? So this is our desired answer. So now from this example, what you can see? You can see that whenever both of them are equal, right? So we will be skipping both of the characters, right? And when both of them are not equal, then we will be either choosing from the first word or we will be choosing from the second word. So this is the thing which we are required to do here. Means this will contribute to our recurrence relation. And now comes the part about the base case. So you can see that all of these strings are like at either moment of time, any of the string could exhaust, right? So here comes out the base case that when either of them get completely exhausted, then at that particular moment only, if other string is still remaining, then our base case would be that we will be adding up all the letters which are being left in our other string, and this is how it contributes to our first base case. And there is one more base case. If all the letters are equal, right? Or if all the letters are unequal, if that is the criteria, then both of them would come up to 0 at the same moment only, right? Means both of the strings will get exhausted, right? So in that criteria, our second base case would be that both of the pointers are now 0. So that's why we will be returning 0 at that moment, because at that time we won't be deleting any character. So that's why we would be returning 0. So this was like verbal explanation that how all things would be done. Now let me show you, because I have also written it, because I know that just verbal explanation is not enough. So here comes the part for recursive solution. For a recursive solution, the first part comes up for the recurrence relation. Before thinking about the base case, we are required to think that what options we are having and how we are required to come up with the recurrence relation. So here the options are, either we are required to choose one char from the word 1, or we are not required to choose char from the word 1. That is our options which we are given this. Now here comes the part that according to that only how we are required to write a recurrence relation, and from that how we will be coming up with a recursive solution. So if both of the characters are equal, the way their EA and EA, in that AA were equal, right? So we were skipping, right? So here also we will be skipping. That's the thing which we will be doing. And if both of them are not equal, right? So in that case, we will be keeping we will be choosing from either first word, right? And then moving ahead by skipping that particular index, or we will be choosing from the second word and moving ahead by skipping that index. That is the thing which we will be doing. But out of them also, we will be choosing minimum. So that is what we are doing here. So this was about the recurrence relation. Now comes the part about the base case. After recurrence relation, we are required to stop that particular solution also, right? So for that particular thing, we are required with the base case. So if one string exhausts, then we need to return other string as well, right? So if both of these strings exhaust, then we are required to return 0. So these are the two base cases which we are required. So this was about the recursive solution. I'll show you the code at the end. But now comes the part that this recurrence relation would surely go to 2 raised to power m plus n time complexity, right? Because we have two choices and total m plus n time we would be having those choices. And the space complexities goes till order of m plus n, because at max the recursive stack would fill up with m plus n. Now comes the part that if this would be the time complexity, then surely our solution will give us TLE as per the constraint, because the constraint was 10 raised to power 3 for the length, right? So in this criteria, what we would be doing is we will memoize the solution. And how we are required to memoize it? So the thing in the memorization is choosing a particular data structure, and how we are required to choose that on the basis of what are the variable parts in the same. So here the variable parts are two, that one is for the first string and the second is for the second string, because these are the two variable parts on the basis of which this whole recursive solution is ongoing. So that's why we would be choosing a 2D either vector, either array, means a two-dimensional data structure we would be choosing here. And then first we would be initializing that with -1, so that could act as a flag that if it is not -1, then surely it would be having some subcase in the same, because you can see in this particular recursive tree that here subcases were there. This particular red portion and this particular red portion, both of them are repeating, right? So we are required to avoid these subcases. So that's why we are memoizing it. So for avoiding this particular subcase, so we are just going ahead for the same, means a 2D vector would be used, and then a -1 as a flag would be used. And now comes the part for the base case, which we would be handling there. So the base case would be the same, the way we are using in this recursive solution. And yeah, these are few things which we are required to do. Else, if any other thing is that, I'll show you in the code, because these are the overview sort of thing. And now comes the part for the bottom-up solution. So for the bottom-up solution, the only thing is, now it was just memoized, right? And now it is using functions. In the bottom-up, we would be completely transforming this particular solution into a tablet form. These all the functions which are used here, now these functions would be completely converted to that 2D data structure. Means instead of this function, we will be writing dp of n-1 m-1. That is the thing which we will be writing here. And instead of this minimum of s of n-1 plus function of n-1 comma m, we will be writing s of n-1 plus dp of n-1 and that m. Basically, they would be indicated now as the indices of that particular dp. And this is how we will be transforming this particular solution into a DP solution. And in that DP solution, the base cases would be handled by making a DP table in such a manner by adding one extra row and one extra column. And by that thing only, we would be able to come up with a base case. Here, our base case was that if both of them are exhausted, means both of the indices are 0, then at that case, we will be returning 0. So there, the table would be formed something like this. Means when both of the indices are 0, right, means here you can see I is basically less than 0 and here j is basically less than 0, so it is 0. But there was one more case, when I is less than 0 but j is greater than 0. Then in that criteria, what we were doing was, we were returning the previous value which was stored there and the present value which was there. That was the thing which we were storing. But here you can see the previous value is 0, right? And the present value, because of these things only, it will be remaining 0 as well. Means the whole row and the whole column, it will become 0. And then here the things would be filled on the basis of the cases which we were using in our recurrent solution. So this was whole explanation about this particular question. And the time complexity and the space complexity, as usual, it would be order of n into m. And the space complexity, that would also be the same for both memoization and bottom up. So now comes the part for the coding of this particular question. So for coding part, let me show you how we are required to code it. Yeah. Let us first start with the recursive approach of this particular question. So for recursive approach, here you can see that how we are doing. This is our main function which is there. So we are starting from return minimum top down. We are putting the parameters as the word, then second word, then a size of the first word, then size of the second word. That is, we are passing as a parameter because we are required with the word itself and the size of that word also. And then at the end we are returning 0 here. If so, this was the thing. Now comes the part for the base cases. Here we are having the two base cases. That if m equals to 0 or n equals to 0, then we will be returning 0. Else if m is less than equals to 0, means one of them is less than 0, then what we would be doing, we'll check for the other word, whatsoever letters are remaining, we'll directly add them up with our answer. That's the thing which we are doing here. Or if other way round comes up, means if n is less than equal to 0, then in that criteria we will be adding up this a of m minus 1 and the whole function. So now in this else part, this is that part when n is also greater than 0 and m is also greater than 0. So in this criteria, now we will be checking that if a of m minus 1 equals to b of n minus 1. If both of the characters which were previously there, if both of them are equal, then in that criteria we will be moving ahead. Else, if both of them were not equal, so we will either check for the first character or we will check for the second character on the basis of which of them is minimum. So this is the thing which we would be doing here, means this particular. That's the thing which we are doing here. So this was for a recursive solution. Now this whole thing would be done as it is in a memorization also. The only thing would be that a 2D vector would be added, that is this particular. And here the thing would be that the size of this particular would be +1. Earlier the size was basically, you can see, it was the directly as it is, the way it is. But here we have taken one extra space also. That would be for handling our base cases. So here at the first we are checking that if there is something in our particular vector, if there is something in our vector, then we will be directly returning from here. And if we reach a base case that both of them are equal to 0, then in that particular criteria we will be assigning 0 at that particular position. If m is equal to 0, then we will be checking for our b, that is for our other word. If n is equals to 0, then we will be checking for our other word, that is a and other solution. And if both of them are equal and both of them are greater than 0, then in that criteria we will be directly going ahead by skipping these indices. Or other way around, if both of them are not equal, then we will be checking that which of them are basically minimum out of both of them. So this was all for the memoized solution. Now comes the part for the bottom-up DP. So for bottom-up DP, what we are going to do, let me comment that down, because else if I run this particular, then it could be like, so that's I don't want to. So here comes the part for our bottom-up DP. So here in bottom-up DP, we are first directly passing as it is. Now in this particular, we are first initializing. Here you can see that I hadn't taken that vector which I used to take. Here I have just directly taken that array. Now here comes the part for this whole bottom-up DP. So in this, what we are doing, we are using two loops for accessing our rows and columns, the as usual way of accessing matrices. Now in this particular, again we have taken +1, means one extra row, one extra column for handling our base case. And here we would be starting from 0, not from 1, because in this particular loop only we are basically, whenever both of them are 0, then at that criteria, we are filling up our base case with is 0. If either of them is 0 and other one is basically greater than 0, then in that particular criteria, we are filling that particular position also as 0, the way I had showed you in that particular segment earlier. So that's what we are doing here. Means if here you can see that if one of them is basically 0 or less than 0 and other one is greater than, so what we are choosing, we are basically choosing the other word which is there and the result of the previous one. The result of the previous one would be 0 and the other word which would be there, that would be directly kept into that. And the same goes for this particular condition. And now once the part if both of them are basically greater than 0, right? And in them also, if both of them are equal, then we would be directly checking for a diagonal element. And if both of them are not equal, then we will be checking minimum out of them. So this is thing which we would be doing in this also, the way we were doing that in the recursive solution and then memoized. And then at the end, we will be returning this. And why we are choosing this M, N and why not I, J, or any other position in that table? The thing is that while filling this particular table, that end position would be that particular answer which is being required. Means the minimum out of all of these selections would be directly stored at the end point, that is at the bottom right position. In these particular type of questions, in LCS questions, I mean the way we are going ahead with the same. So that's why we are choosing for this particular position. Because in the coming up questions, there would be some questions where the answer is not stored at this position, but the answer is stored in the table somewhere else. So when we will be coming up at those solutions, then I'll tell you about the same, that why that is the criteria. But for the LCS solution, most of the solution is stored at the bottom right position, the way it is stored here. So this was all for this particular question. If there's any doubt, you could have comment that down. And yeah, I would like to introduce you about the channel sponsored, means the one who is supporting this particular channel. So that is the Newton School, because as most of the students ask me about the structured course where one-on-one mentorship is there, doubt clearing sessions are there, and a lot of things like these are there. So that's why I would recommend Newton School for the same. And the thing is that one of the best things which I liked about the Newton School is that they don't have any upfront fee. So that's why the thing is that when you will get placement from their course, then after that only you are required to pay their course fee, else you won't be required to pay even a single penny of the fee. So that is the thing. This is one of the best I liked about the Newton School. And further, their placement packages are from 5 LPA to 40 LPA. So it's like pretty much good range. So that's why if you want to prefer going ahead with the Newton School, you can find all details in the description. So yeah, this was all for the same. So thank you.